Last time we talked about polynomials and just kind of reviewed what a polynomial was and did some examples of things that were polynomials and weren't polynomials. And I asked you guys to work on 1 through 4 from the problem set. We'll start with any questions from those if you have any. Not surprising, it was pretty straightforward, right? Like, not a big deal. Okay. Well, that's good. Again, if you guys change your mind, we can always come back and take questions, like it's fine. But, so when we had started this chapter, it was really kind of our big concern here was on modeling, and that's where we're going to kind of move towards today. When we talk about modeling, what we're talking about is creating like a mathematical equation to describe a real-world situation. So in this chapter, there's lots of different types of modeling that, that a person might do. The one that we're going to be focused on in this chapter specifically is going to be regression. And in regression, we're going to use actual data or measurements. And we're going to use that to construct our mathematical model. Now the method here that we're going to be using to do this construction is not going to be by hand. We're going to be using the calculator to do the actual. It's going to take the data for us and spit out our mathematical model, and then we're going to use that to kind of answer questions. Time provided, we might talk a little bit about briefly what the calculator is doing internally to do this, as can give you a little brief overview so it doesn't feel so much like magic what the calculator is doing, but the calculator is going to handle the hard part for us. For this entire chapter, the calculator will do the hard part, which is generating the model. So we're going to be looking to create these models, and the tool we're going to be using is this regression. One of the things that immediately we want to talk about whenever we are creating a mathematical model to describe something, typically when we create a mathematical model, it's going to be a 2-variable model, so it has like height and weight, or temperature and rainfall, or, 2 kind of variables, 2 things that we're measuring. The immediate question that we want to ask after we've built our model is, are these 2 variables linked together in some way? In mathematics, the 2 ways that we kind of describe the way 2 variables might be linked together is correlated or causal. And this is a place where it's very easy to kind of say more than really is possible. So for example, correlated is just going to basically mean that these 2 variables have some kind of mathematical relationship. Causation would be one of these 2 variables is actually causing the change in the other. So for example, we could plot some data about the number of tiger sightings in the presence of this stapler, right? We could track this, and like each day gets another, recorded number of tiger sightings, but they're all going to be 0, right? And you might conclude then that, oh, well, this stapler is a really effective tiger deterrent. Now, clearly that's nonsense, right? But the data would suggest that, you know, like there's no tiger sightings, it must be the cause of this stapler. The two things are just correlated. There's a mathematical relationship, but there's clearly like no logical relationship why this stapler would be, you know, deterring tigers. Has more to the fact that like we're in North America and there's not a lot of tigers walking around. Unless you wander into like the Tiger King's ranch, you know, or something. Does that kind of make sense? We get the ideal difference between correlation and causation. And it's very easy if you're not thinking too hard about the relationship of two variables to assume there's a causal relationship when there isn't one. And there's actually different like statistics that you would use to look for, to sort out whether something is causal or correlated a little bit deeper. And you'd see that in a statistics course, potentially. Not something that we're going to measure here. All we're going to measure in this course is we're going to be looking at correlation. So is the model that we've created well suited to the data mathematically? Is basically all we're going to be looking at. It's not going to tell us whether the two variables that we're creating a mathematical model for are actually one is causing the other, but simply based on the data we've collected, is this a good mathematical relationship we found or not? So I just kind of talked a little bit about these two, but keep in mind that really in this chapter, all we're going to be dealing with is correlating and not correlation, not causation. So when we look at these regression models, we're going to look at several different types of regression models. We're going to start today talking about linear regression. But we'll also talk about like exponential, and logarithmic. Oh boy, is it logarithmic or logistic? We'll just hedge our bets. We'll find out in a moment. Oh boy, everybody's here now, huh?
Yeah.
That's good.
It was a pain driving today.
Yeah, traffic was moving slow for sure. And then we'll also look at power function regression. So we have these different types of regressions, and maybe I'll put some more to be determined depending on how far we go. Just put etc. So when we talk about correlation for linear regression, we're going to talk about correlation using the correlation coefficient. And we abbreviate that correlation coefficient with the letter R. My suspicion is that a pirate came up with that abbreviation. Everybody likes a good pirate joke, right? That's clearly a joke, right? Pirates like to say "Arr!" Okay. So when we again, and to actually calculate this correlation coefficient, this is again something the calculator is going to handle for us. We're not going to actually do this by hand, but I want to talk a little bit about what this is representing, and if you were to just kind of eyeball, like, is this going to have a good correlation coefficient value or a bad one just by looking at some data? one of the easiest ways to estimate what the correlation coefficient value would be of your data is to plot the data. So when we plot data, we call that a scatter plot. That turned out way smaller than I wanted. So if I look at this data, this looks rather linear, right? It looks kind of like a straight line. That we would consider to have strongly correlated, like that's going to have good predictive value when we create our linear regression model. As opposed to something like this, where the data is quite a bit more spread out. Now there's a general like linear trend there. As you move from left to right across the graph, it seems like it's sloping down. But it's not as nearly as tight or tightly grouped as the data on the left. Everybody okay with that? So if we're looking at a scatter plot, we're basically just looking at how much does this resemble a line. If it very closely resembles a line, you're going to have good correlation. If it's just line-ish or doesn't look like a line at all, you're going to have bad correlation. So when we talk about this correlation coefficient, the correlation coefficient is specifically bounded or defined for specific values. So that correlation coefficient is bounded between -1 and +1. And this acts as kind of a continuum. So like over at -1 and +1, down at those poles, we'd consider that to have strong correlation. But down near 0, is considered weak correlation. So as R gets closer to 1 or -1, the correlation is getting better. As it comes in towards 0, it's getting worse. Joe?
So can a correlation go above 1 or below -1?
It cannot.
So that's like the set values that it has to be at.
Exactly.
Okay.
Yes. Every correlation value is between -1 and +1. And in fact, if we get to exactly -1 or exactly +1, what that's actually saying is that that data is actually the data for a line. Like you can make a line that passes through all of the points in your data, as opposed to like, oh, we can get a line that's pretty close to all of your data. And 0 is actually like technically like a theoretical value. You can't actually get a correlation of 0, but you can get darn close to it. And the closer you get to 0, the worse that linear relationship is. So when we say that R is negative, we say that's a negative correlation. And if we have a negative correlation, what that's going to mean is that the linear model that we create is going to have negative slope. And similarly, if that correlation coefficient is positive, we'd say that then is called positive correlation. And what that would mean is that our linear model is going to be aligned with positive slope. Any questions so far about what we've talked about? Okay. So let's take a look at an example here. So here's some data. How would we describe the correlation here? Ariana? Good. I would agree. I would say this is strong negative correlation. We'd say it's strong because the data is fairly closely clumped together in the shape of a line. And we say it's negative because if we're going to try to draw like a best fit line through there, that line has negative slope. Again, negative slope because it's going down as you move from left to right. If we're asked to estimate a value here, you know, if you gave me anything from like negative 0.7 to negative 1, I would say is an acceptable answer there. For if I just asked you to like estimate a value, again, there's not like a number that we're looking for. It just kind of between, anywhere in between those would be good. I wouldn't want exactly negative 1 because it's clear that these aren't like exactly a line, right? But anywhere in there I would say is an acceptable response for you guys. Does that feel okay? Again, fairly easy, just kind of using a definition. So let's look at a numeric example now. Let's make that a little bigger, huh? I'll go bigger. There we go. Okay, so what we have here is a set of data that's measuring the price of a can of soda pop and then how many cans of soda pop were sold during or on that day at that price. This feels like something that there might be a causal relationship on, right? That if the price goes up, you'd expect to maybe sell a little less, although it may not be the only cause of selling a lot of soda pop. What else might also be a strong factor? Right, like maybe the weather. If it's a hot day where people want cold drinks, I'd expect to sell a lot more cold drinks on a hot day, regardless of the price, than I would on a very cold day, for example, right? So although price is certainly a factor, it may not be the only factor in causing some of this stuff. So just again, just trying to stay close to that correlation and causation idea. Although it feels like this, certainly these two things should be related, the cost and the number you sell, right? Those of you in econ, this is a pretty normal supply and demand concept, right? Okay. So first thing that we'd want to do is I'd want to look at a graph of this scatter plot just to make sure that the data looks like it's should be something that would be well described with a line, that the data would be linear. So you could graph this stuff by hand. I would not want to do it that way because it feels like kind of a hassle. I don't like having to be really neat, and this is a case where like neatness would matter a little bit. I'm going to let my calculator handle generating the scatter plot for me. Does it sound good to you guys? Okay, so if you would like to follow along with me, I encourage you to take out your graphing calculator and we'll kind of walk through how to generate a scatter plot.
Sort of like mark all the points for us, basically.
Yeah, it'll draw the graph, just like a graph, just like we looked at before. It'll do the whole thing for us.
That's nice.
We just have to be careful about how we're going to ask it to do that. Okay. So we're actually going to do like several things inside of this example. So we're going to generate the scatter plot. We're going to look at the scatter plot to check to make sure it's linear. Then we'll use that scatter plot to create a linear regression equation. We'll actually ask the calculator to give us an equation that fits this data nicely. And we'll get the actual value for the correlation coefficient from the calculator. So we're going to do kind of three things here, but the calculator is going to handle all of it for us. Okay? So let's start by generating our scatter plot. To do that, we have to enter the data into our calculator. The place that we do that is in the in a list. So we're going to start by pressing the second button. That's the blue button at the top. And then the stat button, which is like 2 over from the green. Oops, I'm sorry. I just meant the stat button. Excuse me. No second, just stat. So you should be in a menu that looks like this. We're going to pick from the Edit tab, the Edit command. And this is the area in which we can enter data into our calculator. A couple of things here before we start entering values. Let's say that some of us came into their menu and you already had stuff in one of these lists. Okay? To get rid of stuff in your list, if you want to just get rid of a specific entry, you can go to that entry and press delete, and it'll delete a single entry. If you have a list that has lots of things in it and you want to clear out the whole list, you need to move your cursor up to the heading. See how my cursor is now on the L1? If you press clear and then the down arrow, it'll empty the entire list for you. What you want to be careful about is when you're up here, not pressing the delete button, because that's actually going to remove the entire list title, like that entire list is going to go on, and the space where you could type things into is going to go away, and it's kind of a hassle putting things all back in the order that you'd kind of expect them to be in. So be careful about that. If you do end up doing that, though, you can certainly talk to Mr. Kulik, and he can help you kind of fix what you did there. It's just kind of a hassle. All right. So let's type in our data, and I'm going to just type it in the same way it's on my sheet of paper here. And you'll notice when I'm typing this in, I'm not going to worry about 2.5 and then typing the 0. The calculator is going to drop the 0 anyways. Because those non-significant digits, the calculator doesn't need to do anything. So I'm going to just type the prices into L1, and then I'm going to type the number of cans sold into L2. Now look at what I've done here. What do you notice? I missed one. That's going to become a big issue, right? If we end up missing one and we go to try to graph the scatter plot, we're going to get an error. So the error on your calculator, it's going to say dim mismatch is going to be the name of the error that you get. And what that error is telling you is that you have a different number of x coordinates than you do y coordinates, and I can't plot these points because something doesn't have a coordinate for it. Either I'm missing an x or missing a y. So if you get that kind of an error, which is easy to do, it's easy to miss typing one in. I just did it there accidentally. That is what the error the calculator would return to when we go to construct our scatter plot here in a moment. Okay, I've got all my data typed in. Anybody still working on typing in their data that's following along? Okay, very good. The next thing I'm going to do is I'm going to prep my graph so that, or my window, so that when I graph this scatter plot, I can actually see the points that I'm interested in. So I'm going to press the window button. Ooh, maybe before we even do this, let's have one more discussion. We're fine staying on this screen, but we need to discuss one other thing. So when we graph these points, one of these data, or one of these variables, the price or the number of cans, needs to be the x, and the other one needs to be the y. Everybody agree with that? We're plotting points. If you remember way back to your Algebra 1 class, the x-coordinate we called the independent variable, and the y-coordinate the dependent variable. So we should think here for a moment about whether the price depends on the number of cans sold, or the number of cans sold should depend on the price. Which one do you think depends on the other? I would agree. I think that the number of cans would depend on the price. That seems like that makes the most logical sense. So what that means is then the price is going to be my x-coordinate, and the cans is going to be my y-coordinate. So when I'm making my window, I want to keep that in mind. Okay? So my window, the x-coordinates are going to have to contain the values from 1.25 to 2.50. So I think going like 0 to 3 makes sense. That contains all of the x-coordinates, right? Because my smallest x-coordinate is 1.25. My biggest is 2.5. 0 to 3 is nice and round, and it contains all the x-coordinates. Everybody see that? Okay. The x-scale, the scale is going to be like where the tick marks are on my axis. So I'm actually going to change that from 1, because if I notice that the change is by, each coordinate changes by how much? 0.25. So that's what I'm going to change my x scale to. It's just 0.25 so that these points line up with a tick mark on the x-axis. Everybody's okay with that idea? Okay. If you didn't change that, is that going to really affect anything though? No. It won't affect the view of your picture if you don't change the scale. Now the y is going to represent the number of cans sold. So my minimum number of cans sold is 80. So the y minimum I need to pick is something smaller than 80. So you could use 0. I'm going to do 50, I think, just so there's not like a giant gap before we get to 80. And my biggest is 207. So I'm going to pick something bigger than that. I don't know, 250 maybe, just sticking with round numbers. Again, the minimum and the maxes don't really matter. They just need to make sure they're smaller than the smallest coordinate and bigger than the biggest coordinate. And you're fine. The y scale here, we're going from 50 to 250. What do you think? How much will go up by? 25 sound about good to you guys? That feels about right. It's going to be like, I don't know, like 8 tick marks or something. That seems appropriate. So I'll go ahead and change that to 25. Again, if you didn't change that, that's not a huge deal. So we've set our window to fit the data that we're given. Everybody's cool with what we did here? And the numbers we chose were just strictly dependent on the data in our problem. So I just looked at the data to do this. Okay. To turn on my scatter plot, then I'm going to press second. That's the blue button, and the y equals button, which is immediately above it. That opens the stat plot menu. So I'm going to pick one of these. It doesn't matter which one, plot 1, 2, 3. It doesn't matter. I'm just going to pick plot 1. I'm going to start by turning that on. You'll see below there's 6 different types of graphs that we can generate from data. For us, what we're doing here in this class, we're only going to be using that first option, which is the scatter plot option. It's just going to plot points for us. The other options you might use if you take a statistics course. Okay, next thing here, it asks for an X list and a Y list. If you remember when we entered data into our calculator, I put the price in L1 and I put the number of cans in L2. And we said the price should be our X coordinate and the number of cans should be our Y coordinate. So this is all set up for me the way I would like it. Does that feel okay to you guys? Okay. And then the last one just is when it plots the points, what mark is it going to show? And I like this using the square because it's easy to see. So I'm just going to stick with that. But it doesn't really matter here. That's not going to affect what you get. Okay. Once we've done all this, let's hit graph and take a look at what we have here. Oh, I forgot to do one other thing that we probably should have mentioned to do. So here's my points. Everybody feel okay there? How many of you also have like a line or something going through here? You might have, because before we really hit that, we should have gone to the y equals menu and just cleared out anything that we had in there. You might have had something zigzagging through there. That's possible. We should get rid of that stuff. Lily?
I don't have anything.
You don't have anything?
No.
Okay. So you might have forgot to do turn the plot on. So if you go back to that stat plot and you pick, did you make sure to turn plot 1 on? So that's probably the issue. Try doing that and then hitting graph again and you should get the scatter plot. If you don't, I'll come take a look. That's good? Okay. Yeah, no problem. Again, maybe we skated past that a little quickly, but okay. So I look at this. Look fairly line-ish? Yeah, I think so. That's reasonably line. Looks reasonably like a line. So what we're going to do next is we're going to generate a model for this. So I'm going to ask the calculator to use the data to create a line. The line that the calculator is going to create is going to be called a line of best fit. And what it does is it's using a specific definition of close. It's going to create a line that's closest on average to every point on the scatter plot. So it's not going to be like specifically through 3 of them and then skip these, or through these 4, but skip those 4. It's going to be kind of equally close to everything. Does that kind of make sense in what we're describing? And there's like a specific set of instructions that the calculator is using to do that. There's several ways to kind of build out these best fit lines. I'm not positive what the set of instructions the calculator is using to do that, but it's kind of beyond the scope of this class to really worry about it. If you take a statistics class or you take the IB Math Studies class, I know for a fact that in that kind of a course we'll talk about like one way to do this numerically. Okay, so let's go ahead and start building this regression equation, this model. So I'm going to just exit out of here by pressing second and then the mode button. And then I'm going to go back into that stat menu. So I'm going to press the stat button again, which is just over from the green alpha. I'm going to move my cursor over to the calculate menu. So the calc menu there. Okay, everybody good so far? And then I'm going to go down. Notice that command 4 says linreg. That's the one that I'm going to be using. Notice that also there are 2 linreg ones. I always just use the first one. So I always would use the AX plus B one. It doesn't really matter, but I'm used to thinking of things as MX plus B. That's the order that I'm comfortable. So I'm going to do that. When I press this button and select the linreg command, it's going to take me to a separate menu. And this menu is going to ask me 4 questions. So the first question it's going to ask is, where is your X data at and where's your Y data at? Again, we typed our price of cans into the L1 list. That was our X coordinate, which is already defaulted on our calculator as the X list. And we typed the number of cans sold into L2, which we wanted to use as our Y coordinate, which the calculator is defaulted as already as our Y list. So we're all set there. The next asks for a frequency list. We'll never use that option in this course, so you don't ever have to put anything there. Again, if you're doing a stats class, it's possible that you use something where you need a frequency list to do something like this, but not in this class. So we don't need to worry about that. The last option says store regression equation. We're actually going to put something here because we're going to use this regression equation to answer some questions in just a moment. So what I want to put here is the calculator is going to create this equation, and then I want it to put this equation into the y equals menu for me so I can look at that equation in comparison to my scatter plot, and then even use that equation to maybe answer some questions later on. Okay? So I'm going to pick a location in the y equals menu to store this equation to, like y1 or y2 or y3 or y4. Doesn't really matter. I'm going to pick y1. Everybody good? So the way I retrieve that variable is I'm going to press the variables button, or vars for short. The vars button is right there below the down arrow. So there's the variables. Since we're talking about storing something into like the y1, y2, y3, etc., what kind of variable are we looking for? A y variable. So we're going to move our tab over to the y variable. And right now our calculator's in function mode, and we're doing everything in this class in function mode so far. So we're going to pick from the function command, or the function option, and then we're just going to pick one of these options. I'm going to just pick y1. Doesn't really matter. And even if you had something in the y1 slot, if you pick y1, I believe it just overwrites whatever's there. So it just clears out whatever's there and puts your new regression equation in its place. So even if you had something there, it shouldn't be an issue. And then we're going to hit calculate. So what the calculator is telling me is that for the equation y equals mx plus b, or I'm sorry, y equals ax plus b, the a is this negative 104.6857143, and this b value is 329.2857143. So if we wanted to like write down our regression equation on our sheet of paper, I can't remember all those numbers. I need to look at the calculator at the same time, so we had to rearrange this a little bit. But you might write like y equals negative 104.6857.143x plus 329.2857143. So that would be like the model that we're using. Joe?
I'm a little confused. So when you went to like figure out A and B values,
Right.
you didn't like create a formula. You just used y1, right? Like, did you write? I think I missed that step.
Yeah, we didn't
You didn't
create.
plug any, like,
I didn't.
formula, right?
So I didn't. What I plugged into the calculator to have it do this is the data that was entered in L1 and L2.
Okay.
So that's what the calculator used to create this equation, was the data in L1 and L2.
So the calculator basically did all the work.
The calculator did all of the work for us,
Okay.
which is lovely, right?
Yeah.
So we've done that. This is like our regression equation or our mathematical model. If I go and I press the y equals button and I look at y1, you'll notice that that equation is already typed in there for us. You see that? That's what the store reg EQ option did for us, is it just had the calculator type that in for us so we didn't have to type all those numbers because it's a lot of numbers to type. If we hit graph now, you'll see that, hey, there's my best fit line going through the data. And if you look, that's darn close to all of those points. Everybody feel okay there? Okay. So one thing we can do with this model now that we've created it is we want to evaluate, like, okay, this looks like there would have good correlation, but what maybe specifically is the correlation value, right? Let's find that correlation coefficient. Now, ideally, when we ran that regression equation and it gave us the values for A and B, it would have also given us the value for R, the calculator would have, if the appropriate option was activated on your calculator. That option was not activated in my calculator. Some of you guys that ran that regression equation, did the linreg, might have got the R value to come up. Did anybody have that when they were following along? Okay. Well, then, like, everybody should do this because you'll need to have this option activated on your calculator to get R values to come out. So if you have your calculator with you, I strongly recommend you pull it out and do this right now. The nice part is, if we do this once, we don't have to do it again unless you reset your calculator, like the battery goes completely dead or something like that. So once we activate this option, we don't have to do it every single time we want to do this. It'll stay there for us. So what we want is the command called diagnostic on. The easiest way to find that command is to just go to the catalog. So we're going to press the second button, which is the blue one, and then the 0. This opens up the catalog. So the catalog is just a list of every single command on your calculator. They're written down in the catalog in alphabetical order. So we want to find diagnostic on. So we're going to skip down to the D's. Notice the x to the negative 1 button above that in green is the letter D. So if I press the x to the negative 1 button, it'll skip all the way down to the D's in my list, which is nice. And then I'm just going to scroll down till I find the diagnostic on command. I'll give you guys a second to get there if you're following along. Anybody still working on getting to diagnostic on? Okay. We're going to press enter. That'll paste diagnostic on onto our home screen. And we'll press enter again and it should say done. Everybody good? Okay. Anybody still working on that? All right. So now if I go back and I redo that linear regression, in addition to getting the A and B values, I'm going to get an R value and an R squared value. We'll talk about what R squared means in a few minutes. So I do stat, and then we go over to calc. We go down to linreg. We select that. I'm going to skip the store reg EQ step because this is still the same data. It's going to give me the exact same regression equation. It's already been stored once. I don't need to store it again, so I'm just going to save those button pushings and hit calculate. And this time, we get an R squared value and we get an R value. Since this is a linear equation, the one that I care about is the R value. And I have something that's quite close to -1, negative 0.96 and change. So this is quite a good model, mathematically speaking. Does everybody feel okay with that? Okay, so what might we be able to do with this mathematical model is we can answer questions like, hey, if I drop the price to $1, how many cans of soup do you think I would sell? right? We can make a prediction, or say instead of charging $1.65, or instead of, maybe $1.65, how many cans of soup I would sell, or cans of pop I would sell. These were pop, I think. Thinking about dinner. Okay, so there's two types of questions we can ask from this. One type is interpolation. This is where we ask about an x inside the range of our x values. So in this case, something that's between 1.25 and 2.5. So if I ask about 1.65, how many cans of pop would I sell if I charge that much? That would be interpolation. The other type is extrapolation. And this is where we ask about an x value outside the range of x values. So in our example here, this would be things that are greater than 2.5 or are less than 1.25. Everybody feel okay on those definitions? So interpolation is inside the range of x values. Extrapolation or extrapolation is outside. Which one of these do you think is more reliable as a prediction?
Probably the ones inside.
The ones inside. Interpolation is a much more reliable prediction than extrapolation, because if I look at my graph here for a second, say I wanted to, maybe I predicted $3 a can. $3 is out here. Where's the point going to be? It's going to be a negative number of cans sold, right? That's clearly nonsense, right? Where you can't sell negative cans. So like you can get into a lot of trouble with extrapolation. The model is not, many models are not so robust that you can extrapolate really far outside of your data set and still have a reliable prediction. So this is a very common piece of using bad statistics or using bad modeling. So this is something that many of us fall prey to, particularly if you're using data to try to model like weather patterns, because it's all about the future. You're never going to be drawing from something inside your data set, because who cares what was the temperature like this long ago? It was in the past. We know what the temperature was. We just measured it. So a lot of your weather models into the future aren't that great because they're extrapolating. They're pulling time in the future. And really the closer that prediction is to the present, the more reasonable it is. If you want to predict what do you think the temperature is going to be 2 hours from now, you probably get a pretty good estimate. If I ask the temperature 2 years from now, well, you'd be really wrong on that a lot of time. You know what I mean? So again, extrapolation, the further out we get from the data set, again, the less reliable even that gets. In general, extrapolation, not tremendously reliable, but you get far away from your data set, becomes really unreliable. One of the challenges with things like prediction. Yeah, Ariana. Absolutely. Okay. So, again, one reason why a prediction might be bad is because we're asking you to do extrapolation, right? That could be one reason a prediction is bad. The other reason that a prediction could be bad is that you have a bad model. How would you know that you have a bad model? The R value is garbage, right? You have a model that's inappropriate to the data that you have, like the type of thing you shaped or you picked. It didn't look like the data. You know, you have some data that looks like a U and you try to fit it with a line. It's like, well, that would also give you lousy predictions, whether they were interpolation or extrapolation, if you have an inappropriate model. Okay, so let's ask a couple of questions here. Let's say how many cans would be sold at 50 cents. So the easiest way to get this value is I'm just going to look at I'm going to be on my calculator, at my graph. My line of best fit is on my graph. I'm going to press the second button, that's the blue one, and the trace command. And then I'm going to select value. And I'm going to type in 0.5 and then press enter. So that the calculator at the bottom then says the y coordinate at 0.5 is 276.9. So I would say about 277 cans. And calculated all the heavy lifting for me again. Everybody feel okay there? Yeah, we'll go through that again. So I press second, and then the trace button, which is up here on the very top row. We selected the value command, and then we just typed 0.5 in for the x. See at the bottom it's flashing x equals, and then press enter. And it'll give you the y value to go along with it. So what did we really do here? All the calculator did was it took our model and it plugged 0.5 in for x and found the corresponding y coordinate, right? So it just plugged it in for us. But again, the calculator handled it. We just had to know how to ask it. Now, what did we do here? Did we do interpolation or extrapolation? Extrapolation. Although, if you look at this, does this seem like a reasonable estimate? Yeah, this doesn't seem bonkers. Now, if we had asked about, what if we wanted to know how many cans would be sold if we charged $5? Is this going to be a good estimate? No. And in fact, what's the calculator going to do here? Now, why am I getting an error here? Clearly, that's a line. It should have a point at 5 something. This gave me an error. It says invalid. What do you think was the problem? My window is too small. Excellent. Yes. So when I use the value command, it can only return points that are actually on my screen. Remember that my x coordinate, my x max was 3. 5 is past that. I can't see that. The calculator can't see that point, so it can't retrieve it. That's why it's giving you an error. So if you're using the value command and you're getting an invalid error like that, it just means that you're looking for something outside of your window. So you just need to adjust your window size. So if I come back here and just make my x max 10 instead of 3, we hit graph again. and I do the value command at 5, it works, no problem. In fact, it says negative 194 cans, which is clearly bonkers. Like, Mr. Kulik, your model stinks. It's like, I know.
So do you write that down?
Well, this would be a question. Sure, you could write that down and make a comment of like, clearly this is a bad model or a bad prediction. What do you guys think here so far? Let's do another example, yeah?
When we go to like on My Notre Dame to check the lessons that you put up,
Yeah.
the calculator stuff shows on there as well.
Yeah,
right?
my whole screen is being captured, so you can always go back and rewatch what I'm doing on the calculator. Absolutely. Haley? Absolutely. Sure. So let's grab one of these problems from the problem set and just do one of these together. So let's do, say, number 11. Okay, so this is one that we'll just kind of do together. Let me actually pull that table and we'll put it in here. We'll do this together as another piece of practice. Actually, we'll put this up here and then just let you guys take a look at it. Oops, where am I going? And then we'll go through it together. That'd be better, right? Give you guys a chance to make a mess out of this potentially and then practice on the calculator stuff on your own. That would be helpful. Okay, so below is a table that lists a group of students' ages and heights. Find a linear regression model and use it to predict someone's height who is 20 years old. Pull your calculator out. Try to do this on your own, walking through kind of some of the calculator steps we've done. I'll kind of get up and walk around here a little bit, and if you get run into a calculator hang up, you can always ask about it. Sound good? And we'll go through it together here in another couple minutes. Peyton. Okay.
I just can't get it back. It says much different. Oh, okay. And I don't have a lot.
Okay. So it says it's in this match, which tells me that can we type. Oh, you're probably using it. Right. Okay. So this is
Is that why it wasn't?
well, it was probably not working before because you were trying to use the data in L1 and there was no L1 there. When you did this app on, you probably left it as L1 too.
Well, that even.
Okay. Well, it didn't see it still said it L1 and L2. Actually, because there's no L1, that's why it's even here because it's trying to explain that it exists.
Okay.
Yeah, of course. Sure.
So I just plugged in my points for L1 and L2.
Yep.
Kind of forgot where I was.
So you'll make your scatter plot.
Okay, so graph it.
We'll go to window. You'll want to make your window so it fits the data.
Okay, so the min and the max.
Yeah, so the
Max is 70.
well,
Right? Are we looking at the age?
again, which one do you think is the independent versus the independent? Which one?
Well, the height depends on the years.
Okay, so the age should be X.
Yeah. So our age will be, can we set it at 14 instead of 13.5?
Well,
Or should we make it 13?
well, you're doing the min.
Oh,
So yeah, I would do 14 or 15 or something.
We'll do 15. And for the minimum,
Something less
we'll
than
do
10.
like 8.
Oh, that's,
Okay. And, I should adjust the Y min and Y max as well, right?
yep.
So 15.
For heights.
Well, yeah, you're right. My apologies. Okay, so the minimum we can make is 15. And the maximum we'll do 75. Right. Now, I think I'm all set, right?
And then you go to the stat plot.
For that.
That's all
This is how you turn the scatter plot on.
Okay. So
One of those. Turn it on.
It's gonna die.
So you're in that 1 and 2 already, so you should be good. You should see it.
Oh, beautiful.
And then you do the stat.
Where is that?
Over to help. And then do the link stuff.
Yeah. Okay, sounds good. Thank you.
So we're gonna put that into live one.
Okay, so I got my mirror.
So you want to build your scatter plot or your so stat. Yes.
Once you get your blend right, use make sure they're not right now.
I don't think you have to do anything with that. There's your line. And you can use that to answer the.
We only do that to save the.
Those are confusing me. I also wasn't there for the like.
We're not gonna look at it.
So, here, this question is, height is gonna be. So, X Mitch, I'm sure, should be smaller than this.
Oh my
Oh, I made it to you. No, I got magenta.
Yeah. And that seems fine. Okay, so now go to the, press second to line this.
Yeah, this doesn't seem like it's a
Turn
range.
it on.
Well, I had my graph, I don't know where to go. I didn't draw my line that's fit, right?
Oh, you did the, like, the calculation wrong.
I don't think so, he was right there with me.
I mean, did you say that?
Okay, so should I say it?
Go back.
Don't feel like it's the worst.
Thank
I
you.
know.
Just
What is that?
if you have it in the,
Oh,
like,
oh,
if you
oh,
have it in
yeah,
the,
yeah.
and then whenever you put it, but you still have to calculate it. That's where you have to put y right there.
Everything is like out there.
So the y there is like
I
That's it?
yeah. And then you have to like input the values there. Here's your power.
So why?
Oh no. You just go to calculate. Second. And value, yeah.
And then this is also not
It's an air invalid, so that means I have to adjust my window.
I know that was right.
So I gotta make my max
That's so cute, do it.
You don't have to.
Yeah. See, I pressed those, but out of order. I had to write
Okay.
I have a lot.
94 inches. Bro, what? Hey Siri. How many feet is 94 inches?
Oh, you did that one. How about 8?
The dude's 8 feet, bro? 7.8 feet.
Do you think that is accurate?
I would hope not. That'd be insane.
I think that's the whole point.
Thank you, Tyler.
Yeah, just the model is.
Dude, there's 13 of them. They can't put this t-shirt, where they got
What up, Ms. Garcia? Good, good. That's done.
the school. Oh, like t-shirt.
The weight thing.
Can I go use the restroom?
I know.
Yes.
I know.
So I got like the everyone actually like.
Where'd you go?
Am I supposed to like write this down?
That's your regression.
Yeah, that was good.
Yeah, am I supposed to write it down? And that's
I think it is.
I always teach her how to define it.
Oh,
And then use it to do models.
that's all I do?
Yep.
So like on the test, it gives like a little key on how to like go into this.
You don't even know that there's like 1 degree. It might be a good thing to put on your half sheet.
Oh, boy.
Or be practice enough beforehand. Well, the problem is.
So like how to like.
Yeah, but like,
So I got that.
Okay, so the last, so you have your regression. The other part asks, use that particular, I'll call someone else.
it's like when I say it doesn't really matter. Well, it kind of does.
I don't know what the things are. You need the player to get to it because
No.
you don't.
I know.
And then just redo that process. And you know all these coming into a second.
Here, I'll show you. Leo, give me your sunshine. Leo, give me that no highlight which you need to
Mr. Schultz. The linear regression equation, that's this thing.
I know that.
So you just would write that. Yeah, in this version, like, when you have it, like, save it, it goes to way more.
But if it's
Yeah, it'll be one of these things like on the test I'll say.
Right.
yeah, you should go read
Okay, so they're already, into the, okay, so press stat, and then edit. All right, let's run through this right quick, and then we'll be done here for today.
Not tall, it's not very tall.
7.8 feet.
Yeah, so
This guy's too tall.
you got 94 inches for a 20-year-old. Does that seem reasonable?
Probably not.
No, how tall is 94 inches?
7.8 feet. 7.83 feet.
7.83 feet, huh?
According to Siri, yeah.
So what do you think, hey guys, tune in for a second. So we got 94 inches or 7-something feet for a 20-year-old. What do you think is wrong with this? Why do you think we're getting such an unreasonable value? Because
the person at 10 years old is already super tall. Or actually, it's probably wrong. But
okay, so I would say there's a couple of things going on, a couple of reasonable answers here. One, what type of prediction are you doing if you're asking about a 20-year-old? Extrapolation, which we know is not particularly good. The other issue is, what age are you typically growing the most during? Heights?
14.
Well, I would say even middle school is where you're growing the most, right? Like at 14, it's kind of slowing down for a lot of us anyways. So you've picked the place where you're growing the most to use to predict how tall you're going to be way in the future. Maybe not a great predicting, you know what I mean? So that I think is another piece of your issue. Ugh. Did I? I must have. Sure did.
Oh, there's another 60. Wait, no.
$56, $54, $63, $61, $60, $63.
Oh, you put 211. There's only 21.
Ah, that's easy to fix then. There we go. Okay. I look at my graph. Pretty linear. R value is nice. I go and I extrapolate though. 94 inches. Probably not a great estimate. You guys feel okay? All right. At this point, you guys should be able to do up through, let's say, 12. 12. Yep.
12.
Well, we already did 1 through 4, ideally. So 5 through 12 is the next piece.
Is 5 to 12 due Sunday?
No, nothing is due Sunday.